Which programming language is the best language? Probably every software developer has heard this question before. And if you know it, it's usually when there's either a heated discussion coming that might be a bit entertaining, or it's a totally pointless argument and people are just arguing and maybe even getting angry. So to describe it for non-technical people, it's basically like when you go to a random group of humans and you ask them, hey, what's your favorite food? Or what's your most favorite travel destination? What car brand do you really, really like? Or similar things. It's the same with programming languages. It's very subjective, and context and personal tastes matter a lot. However, sometimes you have objective criteria to actually measure things, and that's when it becomes really interesting, in my opinion. I recently stumbled upon a research paper, and it is called Energy Efficiency Across Programming Languages from Rui Perara and a few other researchers. I'm going to link it in the description for you if you're interested. Now, performance benchmarks for execution speed and memory consumption, they are nothing new. It's pretty well known that you test maybe algorithms for these characteristics. Energy consumption is a rather new factor to consider for IT. And even when it's considered, it's usually at the hardware level or at the algorithm level. So how efficient is an algorithm, or how much energy do I need for this server or cluster or hardware setup, whatever. And now I want to share a few of my key learnings from this paper that I learned from reading it. So one thing is that compiled languages are usually the fastest in terms of execution speed and most energy efficient. So that's not a big surprise here if you're into IT. But there are some virtual machine languages that can actually compete with them. So C is basically the reference point and has an energy score of 1. Less is better. So 1 as an energy score means it's basically the baseline for low energy consumption, in this case at rank 1. It turns out that Java has an energy score of 1.998, so a bit below 2, and is therefore ranked 5 in this list. And that's actually the highest position of all the popular languages that they looked at that does not compile to native code. So rank 1 to 4 are all compiled languages, and the VM-based language at rank 5 is Java. So you heard that right, good old Java is pretty efficient in terms of energy cost. And I think that's pretty impressive when you consider it's not a new language and there's a lot of abstractions in there. You have to, give some credits there, I guess. Then interpreted languages. They are usually way less energy efficient, according to this research, than their compiled competitors or VM-based colleagues. So as an example, pretty good were Dart and JavaScript. They are still pretty decent. They have a score of 3.83 and 4.45. That's pretty good. Compared to, for example, Ruby or Python, which are significantly more expensive, and they have an energy score of, in the case of Ruby, almost 70, and Python is at 75 and a few digits. So there's a huge factor between this and compiled or VM-based languages. That doesn't mean it's a bad language. I really like Python, and I know a lot of people who are into Ruby. It's probably a really good idea to learn these languages for certain use cases, and you can be really productive with them. But in terms of energy cost, it seems to be pretty inefficient, according according to this research. And the third and my last major learning was that energy efficiency tends to correlate with execution speed, although not always. That's not so surprising, but it's not true for memory consumption. So when you consider memory consumption, the ranking for this is quite different from the ranking of efficiency and execution time. So for example, in the paper you can see that Pascal and Go are ranked pretty high on the first two places in terms of energy, in terms of memory consumption. And then C and Rust, which are also pretty efficient, but surprisingly a bit below them. Not sure how that comes. So of course they took some normalized environment to measure that on specific hardware, and they ran algorithms with existing implementations. If you're interested in the details, feel free to read the paper. I can highly recommend it. Thanks to Josh Long, he actually referenced this paper in his talk at Devoxx Belgium about Spring Boot 3, and I really liked his talk and then looked into this paper. Now, I would really like to see research on the topic of developer productivity and to compare it with those efficiency metrics. I have a strong feeling that languages like Python or Ruby would score very high in terms of developer productivity. And it is less true for languages like C and C++, which are really great for machines, but less productive for humans. So if you know anything about that, if you know any research on the topic, please let me know. And tell me what your opinion is about these learnings here.